Absolute value equations and inequalities. Let's start with what is an absolute value. An absolute value of a number is the distance from zero. And because it's a distance, what does that mean? That means it has to be a positive. Wouldn't make sense to measure a room and say, oh, it's -5 feet, okay? So positive. So when we look at this, now the two bars on either side of 4 mean absolute value, and it says take the absolute value of 4. Well, that seems plain and simple and easy, and all of us would probably go ahead and say 4. But here we are at 0, 1, 2, 3, 4. Yep, distance from 0, 4. Now let's look at B. Distance from 0 of -4. How far is -4 from 0? And automatically you should be thinking for sure 4. But let's really visualize it, see it, so that we keep that in mind. Absolute value is always positive. Absolute value, always positive. Alrighty, so then C, how far is -72 from 0 on the number line? 72, and of course 36 is 36 units from 0 on the number line. So now when we have equations, absolute value of x equals 2, we have to stop and think about any possibilities that are 2 units from 0. So when I go through this, I want to go ahead and have that number line to think through and go, okay, so +2 is 2 units and -2 is 2 units. So x can equal 2 or x can equal -2. We need to make sure and have both values present. So then let's get to absolute value of -58. How far from 0? Wait a second. Can an absolute value be negative? No, absolute value always positive. So this is a very easy problem because there's no solution. There's no way an absolute value can equal a negative number. All right, now let's look at the next one. Oh my, 2/5 x minus 5/3, absolute value of that equals 7/3. So remember that this value inside the absolute value bars can be 7/3 units, right? So we have to consider both sides. I want you to get in the habit of writing it out. 2/5 x minus 5/3 equals -7/3, or 2/5 x minus 5/3 equals +7/3. And then we just have 2 equations to solve. So not really harder, but you do have to remember the initial setup. Okay, here's when I like to remind you of that inverse property of multiplication. So when we get to the 2/5 x, let's make sure multiply by the reciprocal. Yikes, that one's not working. 5/2, and do that to both sides of the equation, of course. And look how nice it works out with the fractions. Boom, the 2's divide out, and so I just end up with x could be -5/3. Let's go over to the other side, do that one. Add the 5/3, we get 12/3. And of course, multiply by the reciprocal. Now the 2 can divide into the 12 and it gets to be a 6. And then we have x equals 6 times 5, 30, divided by 3, which of course is 10. So those are the 2 values that places this expression, the absolute makes this positive no matter what. So review that setup. We had the absolute value equal to 7/3. I rewrote it as 2 separate equations, one of them equal to the -7/3, one of them equal to +7/3, and it worked out. We got our 2 possible values. I want you to try D, pause right now. Okay, so D, I got x equals -2 and x equals 3. So check your answers, check your work there, pause if you need to. As I look over at E, what do you notice is different about E compared to the other ones we've done so far? Yeah, there's these extra things hanging outside the absolute value bars. So my absolute value is not isolated, so I don't know how to break up my equation. So what I need to do first here is isolate this absolute value. So I need to get rid of this 1/3 and get rid of this -2. Now think about it. Which one am I going to do first? That -2. I'm going to add 2 to the other side, work in PEMDAS in reverse. So I've got my 1/3 absolute value 3x minus 6 equals 7. And then 1/3, how can I get rid of 1/3 in one fell swoop? I can multiply by the reciprocal. So multiply by 3/1, whatever I do to one side, I have to do to the other. Okay, so now that divides out my 3's, and I'm gonna have absolute value of 3x minus 6 equals 21. Now here's where you need to be extra careful. I can't just go add this 6 right now and keep solving. I still have these absolute value bars. So now I got to consider, okay, that distance from 0.
I could have 3x minus 6 equal to negative 21, or it could be equal to positive 21. So there's my two equations that I can now solve.
Go try
it. Looks like my two solutions are x equals negative 5 or x equals 9. So go try f on your own. Remember to isolate that absolute value first.
Okay, you should be feeling pretty proud if you got x equals negative 5 and x equals 1. Look at this next one we get to do. So this one is set equal to an expression, and we still deal with it the same way. We have the absolute value bars, so we're going to break it out of the absolute value by setting it equal to the negative value and the positive value. But because it's equal to an expression, we have to be super careful. Watch your math notation here. So we take this, it's already isolated, so I'm just going to go ahead and rewrite negative 2x plus 9 equals the opposite parentheses 3x plus 10. Please, please, please. I know you can do that in your head, but you make mistakes sometimes. So just really show it. And then, of course, the second one, negative 2x plus 9 equals the positive expression. So over here, we'll go ahead and start solving. Now, you've had plenty of opportunities to practice solving equations, so just go for it and then come back and check with me. Negative 19 and negative 1/5. Okay, but hate to tell you, there's a little something extra here. Sometimes this gives us an extraneous answer. Extraneous? Yeah, extraneous. That means it's a false solution. So the bad news is we have to go back and check these. We absolutely have to check these two answers because it could be one of them's false or both of them's false. Maybe they both work, but we have to check. So let's plug it back in and check. What? Wait a second, negative 67 plus 10, maybe I didn't even have to multiply that out. Because can this absolute value equal a negative? No, so I would have just been able to stop. As soon as you see absolute value equals a negative value, we're done, cut it. So this is extraneous. Let's practice writing this, people. Extraneous solution. And then I also like to go up and go, cannot equal negative 19. Let's make sure everyone understands. X cannot equal negative 19. Now it'd be nice to just assume that the other one's fine, but we have to make sure it is. So let's plug it in too and verify. Look at where we're at now. So we end up with 9 2/5, and I can keep the mixed number if it's okay, like an absolute value. So then 9 2/5, that's fine. Does that equal negative 3/5 plus 10? Yeah, it does, because we'd subtract 3/5 from 10, have 9 2/5 left. So this one works. We have verified that solution. And now you get to try the next one.
Okay, let's check your setup real quick before you get too far. Did you distribute that negative and get plus 5 there? Be careful. All right, let's check our two solutions here. One is x equals 3/7, and then I have x equals 7. But remember, like Mrs. Peart said, we gotta check for those extraneous solutions. So we have to check our answers here. All right, so checking my first solution. When I plug in 3/7, so make sure, remember when you check your solution, you're checking it with the original, so the one with the absolute values. So absolute value 3 times 3/7, so here I can put that little 3/1, that's gonna be 9/7, plus, and then 2. Equals 4 times 3/7. So put my 4/1, 12/7 minus 5. Okay, so it looks like I'm gonna get a positive answer here and I'm gonna get a positive answer here, but let's make sure this really, really works. So 9/7, if I multiply my 2 by 7/7 really quick, it's gonna be 9/7 plus 14/7 equals, okay, the 5 gets multiplied by 7/7. 12/7 minus 35/7. Look at that. I'm going to get a negative here and I'm going to get a positive here because all absolute values have to be positive. So this is not going to work out because an absolute value cannot equal a negative. So what does that mean about my 3/7? It's extraneous. Just because 3/7 was extraneous doesn't automatically mean x equals 7 is going to be a solution. X equals 7 could also be an extraneous solution, so we have to check both. All right, so when I plug my solution 7 into my original equation, I end up getting the absolute value of 23 equals 23. That is a true statement, so it checked out. So x equals 7 is a solution. 3/7 is an extraneous solution.